presentation will be burner satellite success. And Nikola, we're delighted to hand over to you. The virtual floor is yours.
Thank you, Jim. Can you just confirm that everything is okay, that I share my screen?
Yes, perfect. Yeah, can see you and hear you.
Excellent. Good afternoon, everyone. First, I would like to thank you for giving us opportunity to present our company and our findings. We are excited to share result of our research, which has been going for several decades. I have to say that most of our research, especially in product development, is conducted in collaboration with our clients, and as we work together to effectively respond to all market and process demands. I will share some specifics of our work about the kiln burner and satellite burner and how we can assist clients in burning secondary fuels more efficiently. At the end of the presentation, I will also share some case studies to illustrate our results. First, I want to briefly discuss the types of secondary fuels, where and how they can be fired, and what considerations are necessary when using secondary fuels. Next, we will briefly cover firing through the main burner. Then we will move to our main topic, satellite burner, which has become increasingly important in recent years. And I will conclude the presentation with case studies that illustrate the use of both the main burner and satellite burner. I would like just briefly to introduce Unitherm Cemcon for those who may not be familiar with our company. Unitherm was founded in 1945 in Vienna, initially focusing on producing oil boilers and household heating systems. Over time, we expanded into other industries, and in 1953, we installed our first kiln burner. Originally, we used 2-channel and 3-channel burners until finally we patented MIS technology in 1992. MIS stands for mono-air duct system, which was an innovative solution to bring complete primary air flow into a mechanically adjustable swirler with a minimum loss of momentum. In 1997, there was a change in ownership, and Mr. Lederer acquired the company. Under his leadership, company strategy shifted to primarily focus on cement and mineral market, particularly applications involving rotary kilns. Since then, we have relocated to a new office building and continued to concentrate exclusively on these two industries. We have installed over 600 firing systems in 92 countries up to date, and all of our burners are completely designed and manufactured in Austria. Many of you are likely familiar with Unitherm range of products. We provide complete range of firing systems necessary for cement and mineral industry, including natural gas and liquid fuel handling systems. Our flagship products are MIS and MIS DT kiln burners, which are available in various configurations to meet the needs of different markets, of course. We also offer a specialized version for firing of natural gas. Additionally, we conduct tests with hydrogen, traditional fuel, secondary fuels, and all of our products are designed to meet high standards of efficiency and reliability. For more information about product portfolio, you can visit our website or you can contact me directly. Now, moving to our topic. Here you can see a picture that illustrates a variety of secondary fuels which are available in the market with various levels of preparation. We need to distinguish secondary fuels which can be fired at the main burner and and those which are not suitable for main burner, but rather for calciner. Even the best burner, kiln burner, cannot efficiently use fuels with excessively high moisture content, large amount of 3D particles or oversized particles, because we have physical limitations that we must consider and we cannot avoid. We have created a small diagram to demonstrate how different firing technologies can utilize secondary fuels with different characteristics. Here you can see that with commercial burner, which means simple pipe through the main burner, we can handle very small range of secondary fuels with low moisture content and small particle size. With our pneumo-deflector technology, we can handle higher moisture and bigger particle size by influencing on the behavior of particles as they exit the burner. I will discuss this in details later. To expand the range of usable secondary fuels, next step is satellite burner. And this burner offers even greater flexibility in terms of moisture content and particle size. Additionally, combustion in pre-calciner provides even more freedom as it does not require a precisely defined flame, but rather the release of heat over a longer period of time. However, there are several considerations to keep in mind when starting to fire secondary fuels. Firstly, compared to primary fuels, we need a higher oxygen content at the kiln inlet, typically around 3 to 5%, to ensure complete combustion and to avoid presence of CO at kiln inlet. Additionally, depending on secondary fuel type, we may need to adjust our raw mix to achieve desired clinker quality. For instance, using RDF for plastics often introduce additional sulfur and chlorine into the system. There is also the effect of increased kiln inlet temperature, because even very well prepared secondary fuels are not as refined as coal or petcoke, which means that they take longer to combust. This delay in combustion and heat transfer to clinker can result in higher inlet temperatures. It is definitely crucial to have a main burner that provides flexibility to make all the necessary adjustments. And also, we must take into account that we introduce additional moisture from secondary fuel and additional cold air introduced by pneumatic transport, as these factors also increase the specific heat consumption of the system. As mentioned earlier, shortly after our focus shifted to rotary kiln process in cement industry, we began delivering burners with secondary fuel firing capabilities. Initially, this meant a simple pipe through the main burner, but since then, we have been dedicated to finding solutions to increase volume of secondary fuel that can be fired through the main burner by influencing particle behavior when exiting the burner. Our innovation and proven solution in this development is pneumo-deflector, which has been in use for more than 1 decade. Primary goal of pneumo-deflector is to deflect particles above kiln burner axis, influencing fly path and extending residence and combustion time. In this photo, you can see a burner which is equipped with 2 secondary fuel pipes. Each is equipped with pneumo-deflector. These are small holes at the burner tip. Typically, these openings are supplied by primary air, but they can also be supplied by separate blower, and also they can be adjusted from cold side of the kiln. A number of openings, inclination, and air supply quantity are key parameters for successful design of pneumo-deflector. Our research has shown that while various methods were attempted, including increasing injection speeds and using swirl, only deflecting particles above kiln axis effectively extends residence time and promote combustion. Over time, we successfully identified the optimal injection speeds and angles for each type and quantity of secondary fuel. With the use of pneumodeflector, we increase secondary fuel volume through the main burner by 10 to 15%, of course, by maintaining a consistent clinker quality. This was a theoretical part. Now we have some examples. On the first photo, you can show injection of secondary fuel with pneumodeflector turned off. We can see how material is rapidly falling toward the clinker with a low residence time in a flame. On the second photo, we can see the effect of pneumodeflector in operation. Yeah? So material is deflected upward, which results in significantly longer residence time. For this particular case, combustion optimization was achieved with assistance of our partner company. It's CTEC from Germany. They use their Inspect Pro control system, which is equipped with infrared camera. And for more information about this product, you can visit their website. Here on this video, we can see processed infrared video, which is provided by CTEC with pneumodeflector in operation. And we can see how the material is deflected upward. With this way of process control, we can even have a higher substitution radius. Our next topic is a satellite burner. By the late 90s and early 2000s, with introduction of secondary fuels in cement industry, all the leading burner suppliers, including Unitherm, are focused on injecting secondary fuel through a dedicated channel in a main burner. A few years ago, to be precise, in 2014, driven by the imperative to further increase substitution ratios, Unitherm recognized the potential of the concept of satellite burner, which originated from 1980s. As a result, we initiated development of a new design for satellite burner, which led to first round of test, immediately exposing several obvious advantages compared to firing through the kiln burner. First advantage is the placement of satellite burner. It is positioned above the main burner. It offers an optimal environment for material injection. This position initiates crucial processes such as moisture evaporation and devolatilization, even well before the material reaches the main flame. Second, as you can see on CFD simulation, where we see here marked with the red concentration of oxygen, we inject secondary fuel into the oxygen-rich zone, which additionally optimizes combustion efficiency. Moreover, implementing a satellite burner requires adjustments far beyond the simple fixed pipe. Satellite burner is engineered for axial, horizontal, and vertical adjustments. And these adjustments are essential for finding of ideal location to introduce secondary fuel particles into the main flame. Additionally, when satellite burner is integrated with the main burner, which is capable of adjustments in any direction and which is having high burner effective momentum, Satellite burners improves combustion dynamics even further. Here you can see our MIS burner with flexible hoses, or in new execution, it is with rotary discs, which enables us to shape the flame to perfectly respond to requirements from satellite burner to boost fuel substitution ratio. High effective momentum, high flexibility, and fast response are key features of MIS burners. Here, you can see common setup where satellite burner is positioned directly above the main burner. It is mounted on a small burner trolley, offering an adjustment range of plus or minus 500 millimeters in the axial direction. And separate satellite burner trolley enables vertical and horizontal adjustments of the satellite burner, which is crucial in optimization of combustion process. Installation process differ depending on whether the satellite burner is coming with a new main burner or it is added on existing one. If added to existing burner with an existing burner trolley, then finding of appropriate placement for satellite burner becomes essential. With our satellite burner, we offer two execution options. Firstly, for suspended design, burner frame can be installed beneath the main burner. This configuration frees up space above the burner for satellite burner placement. And also we have floor-mounted placement. It's less complicated as there are no obstructions above. As shown earlier, installation involves placing rails on top of the main burner and securing the satellite burner accordingly. Yeah? Let's go to some case studies. Firstly, we have a case study from cement plant Vasilico, Cyprus, with capacity of 6,500 tons. We install a MISDT burner with thermal capacity of 115 megawatts, which is equipped with secondary fuel channel with pneumo deflector. And it is prepared for future installation of satellite burner. Here we can see burner photos. We can see that the burner is equipped with semicircular solid fuel channel, which enables us to effectively utilize the burner size for maximizing fuel feed rate. In this example, we started with 6 to 8 tons of secondary fuel. During commissioning and later during process optimization, we reach 14.5 tons with stable operation without impacting clinker quality. We have a case study for a plant in Southern Europe. Plant capacity is 4,000 tons per day. To increase substitution rate to the kiln and to reduce the input of cold air, the existing old burner was replaced with a new MISDT burner, which was equipped with satellite burner. With capacity of 79 megawatts, burner is capable of firing coal, natural gas, liquid fuel, and solid fuel through the central pump also. With the old burner, plant could reach feed rate of 4.5 tons per hour. And during commissioning and later during process optimization, we reach 7 tons per hour with stable operation and without impacting clinker quality. As I mentioned earlier, since 2014, the number of satellite burners we installed has steadily increased. Currently, we have more than 50 satellite burners installed, with some still in project phase or under manufacturing. With only few exceptions, our clients show a clear preference for satellite burner technology. And this preference is due to several key reasons. Firstly, retrofitting of existing system with satellite burner can be very easy in some cases. Secondly, when purchasing a new burner, the cost of a burner with integrated secondary fuel channel or with a separate satellite burner is quite similar. However, satellite burner offer more flexibility and greater adjustment capabilities. Thank you very much for your time and attention. If you have questions, please feel free to ask.
Thank you, Nikola, very, very much. Most interesting presentation and the most interesting concept about the satellite burners. And I see you have a question coming in that, by the way, any questions, please input on the Q&A box and they will come to myself and the speaker. I have one question in commenting that this burner with excess air and poor combustion characteristics, secondary fuel, the NOx will also increase. That's something I have found in analysis, actually, that the more alternative fuels that are used in a kiln, the megajoules per ton actually increases. The kiln becomes less efficient. So that obviously is suggesting that burners need to be modified when you are using higher percentages of alternative fuel, or indeed using a separate satellite burner.
Absolutely, this is a clear physics or chemistry because cold air is cold air. So any cubic meter of cold air is a bet for. It's better to utilize a secondary air from the cooler instead of increasing the amount of transport air. That's number one. Second, we can, in average, we have secondary fuels with moisture content above 10, so 10 and more %. So to evaporate the water, we need 600 calories per kilogram of water. So how many kilograms of water we introduce? We need to consume heat to evaporate it. And these are the key reasons. There are other reasons, but these are two main reasons.
Thank you. Two other questions have come in. One is, how do the satellite burners affect kiln coatings? And the second one is, does the pneumo deflector impact the life of refractories since the path is parabolic above the kiln axis? So both questions referring to kiln coatings.
Yeah. It is always about optimization. So we have tools with our tools, we can adjust the system to run smoothly. There are also limitations of the system. We cannot feed 100% or I don't know, depending also on the quality of the fuel. Coating it can be, of course, if we introduce too many sulfur or too much chlorine. This depends on the quality of fuel. And yeah, pneumo deflector, I can say that in this graph, it is just to illustrate, it is theoretical. In practice, material should not touch the refractories or should not touch the coating. So it is a little bit illustration. In infrared video, we can better see how it really works. So it is not really affecting on the coating if adjusted properly.
Interesting, yeah. And another question came in, is your satellite burner also usable for dried sewage sludge?
Yeah, it is not actually in our diagram from beginning. It is somewhere on the border sewage sludge. Maybe can be, but with special preparation. It is a little bit, sewage sludge is a difficult material to handle for pneumatic transport in general because of the high content of grease, of oil. It is really greasy.
And final question, maybe, what type of alternative fuel do you think is the most effective in reducing coal fuel energy? And is there a special configuration for the burner, in your opinion?
We have the most experience with the fluff with RDF. Yeah? So this is the fuel which is very available. It's available everywhere. And we know how to use it properly. So I would say RDF. Animal meal is also not bad fuel, but it's not really available. And it's more expensive. So with RDF, we get a cheap and good fuel. Of course, preparation is crucial, I would say, to increase substitution ratios. Material needs to be prepared. So this means that we need to see material in our graph in the lower part of the graph, which means somewhere around 10% to 12% moisture. Definitely very important not to have 3D particles. So all the particles should be 2D measurement with the third dimension less than a millimeter. And I would identify this as a best fuel for satellite burner.
Okay. And finally, there's a question, is there any problem with red spots using this kind of burner?
Yeah. We have satellite burner is having one very important feature, and this is the phase which I explained briefly when I was speaking about satellite burner. So we shape with the two burners, we have a one nicely shaped flame, which means that we don't have second flame. Therefore, we should not have hotspots. Hotspot is not really related to a satellite burner implementation. With satellite burner, we have one shape, one flame, nicely shaped, and no double flame. This is let's say common effect of burning too much secondary fuels.
I see. Okay. Finally, is the satellite burner, does it need extra primary air?
We need a transporter. So this is number one. We need a transporter, and we have a cooling air. Our satellite burner is equipped with a cooling air channel, and we need this to maintain structural integrity of the of the burner, because every burner, even the main burner, is also cooled. In this case, with primary air. In our case, satellite burner is cooled with. It is a small amount. It is roughly, I can say, 1,000 cubic meters per hour of cooling air.
Okay, Nikola, it's been most interesting, and clearly the number of questions coming in shows great interest in your satellite burner technology, and people can follow up with the presentation afterwards, and your contact details are given as well in your presentation. Well done, Nikola. Thanks for a most interesting presentation and a valuable contribution to our knowledge in the area of pyro processing. So thank you, Nikola, for your presentation.
Thank you.